Good morning children, stay safely at home. So in the last lecture I discussed about the EMF of the cell, terminal PD of the cell and the voltage drop across the cell. Okay, and what is the relation we have got? That EMF of a cell is equal to terminal PD, which is denoted by big V, plus the voltage drop across the cell. Alright. Now you see, according to Ohm's law, you can write this V, the terminal PD across the cell. Just try to understand it when you are connecting the cell with any external circuit. So external circuit is providing one resistance R and you are considering the PD across these 2 points A and B. So you see, according to Ohm's law, potential drop is equal to current multiplied by resistance across the circuit. Okay. So if you consider A via the external circuit till the point B, then what is the resistance offered? By the path big R, that is the external resistance, multiplied by current will be the terminal PD. Now, what is the voltage drop? Voltage drop is the potential difference across the electrolyte of the cell. Okay, so you see, according to Ohm's law, you can write potential drop across the cell, it will be current into internal resistance of the cell. So today, first I will discuss what is internal resistance. Remember, internal resistance of the cell. And when I am writing resistance, then resistance of the conductor, resistance of the external circuit. So don't please write only the internal resistance, only the resistance. Okay, write whose resistance it is. Internal resistance of the cell. So what is the internal resistance of the cell? The obstruction offered by whom? Obstruction offered by electrolyte of a cell to the flow of current within the cell is known as internal resistance. Alright. So, what is internal resistance? The opposition or obstruction offered by electrolyte of a cell to the flow of current within the cell is known as the internal resistance. So, next is the factors on which internal resistance. I am writing here smaller because you see smaller is what? Internal resistance, already written here. So, you can refer to this. Factors on which internal resistance depends. Alright. The first factor, distance between the electrodes. I hope you can remember that EMF of a cell does not depend on the distance between the electrodes, but internal resistance of a cell depends on the distance between the electrodes. So, how it is depending? So, you just try to remember how the electric cell works. If there are two different metals, you are dipping it in the same electrolyte. Then you see what is the passage of current. This is the flow of current if it is positive terminal and if it is negative terminal. So, you see when the current is flowing through the cell, this portion of the electrolyte, through this portion of the electrolyte, the current is not flowing. Current is flowing only through the electrolyte between the two electrodes. Alright. So, you see distance between the two electrodes, when it will increase, then the length of the electrolyte through which the current is passing is increasing. So, what will happen? It will offer more resistance to the flow. Okay. So, what you can write? How does it depend? Greater the distance, higher is the resistance. Internal resistance. Okay, you don't have to write what is the reason that I have explained. Just you write down how does it depend. That greater the distance, higher is the resistance. Now the second factor on which internal resistance of a cell depends is the surface area of the electrode within the electrolyte. Okay, so understand again the basic of the current produced by the cell. You know that whenever you are dipping the metal surface within the electrolyte, then what is happening? One metal surface, it is gaining more electron and becoming negative potential, and another surface which is losing electron, okay, becoming positive potential. So a potential difference created and current is flowing. More the potential difference, more will be the current flowing through the current that can be drawn from the cell. Okay, so you see, if you dip the more area within the electrolyte, then what will happen? It will be accommodate or it will lose more number of electron, so the potential difference will be higher and it will be able to give more current. So when current is more, then what will happen to the resistance? Resistance should be less. So we say greater the area of the electrode within the electrolyte, less is the internal resistance. So here I have not written what is the cause, but verbally I am discussing. So those who are interested for extra information, you can kindly note it down in some other places, but for the exam, those who are trying to write down, they only write down this, that greater the area, less is the internal resistance. But please do not try to apply your brain and do not write that they are inversely proportional. Okay, they are not at all inversely proportional, but you should write down the thing this way, that greater the area, less is the internal resistance. Then the next factor on which internal resistance depends is nature and concentration of electrolyte. Now if the electrolyte is more ionic by nature, then it will offer higher internal resistance, because when it will be less ionic by nature, then it will offer higher internal resistance. And if the concentration of electrolyte is higher, then also it will offer higher internal resistance to the flow of current. Then the last point is temperature of the electrolyte. When the temperature of the electrolyte is high, then what happens? Electrons, as they are lighter particles, their mobility increases. Mobility means what? The speed means the speed developed within the electrolyte per unit electric field. Okay, so mobility more means what? Electron can move with greater speed. So when the temperature of the electrolyte increases, then the mobility of the electron increases. As a result, current increases. So we say internal resistance, it becomes less. Okay, so what is the reason? That higher the temperature of the electrolyte, less is the internal resistance. So these are the four factors on which internal resistance of the cell depends. Now different relations between EMF, terminal PD and the voltage drop, and also in terms of the resistance and current. So you see, I can write like this. So you can write what is the current in the circuit. It is EMF divided by total resistance. So this is one relation you are supposed to remember to solve the numericals. That total current in the circuit is equal to net EMF divided by total resistance of the circuit. Then another one is terminal PD is given by EMF minus I into R. Okay, so while discussing the differences between the terminal PD and EMF, I said that terminal PD, just try to remember, when the current drawn from the cell increases, terminal PD decreases, but EMF of the cell remains the same. So this is the reason. You see, EMF of the cell is the characteristics of the cell. Okay, so it does not depend on it depends only on the nature of the electrode, nature of the electrolyte, but it does not depend on current drawn. But you see, look at the expression, terminal PD is equal to EMF minus I into R. So more the value of I, greater the value of I, then what will happen? Less will be the value of V. So that point, it has come from this relation, that terminal PD is equal to EMF minus IR. But remember that this is the relation when current is drawn from the cell. Current is drawn from the cell, then you can write terminal PD is EMF minus IR. But when you are charging a cell, so just understand it, this is the cell you are charging. So how we connect the charger? I hope every day you do for your mobile, and you have seen how you connect. The positive terminal is connected to the positive terminal of the charger. So this is the charger, alright. Suppose this is the charger. You are connecting the positive terminal of the cell with the positive terminal of the charger, negative terminal connected to the negative terminal of the charger. So here understand it. How we send the current through the cell. We send the current through the cell opposite to the direction of current that the cell provides us. So in this case, you see, in normal cases, when the cell is giving you current, the current is in this direction. Okay, anti-clockwise. But you see, if this is the correction, when charger is charging the cell, then current is flowing in the opposite direction. Alright. So terminal PD, you can write it, it should be EMF plus I into R. Why I have written the plus sign? Because you see, here the sense of current in this relation and the sense of current in this relation is just opposite. So as it is a negative one, sense of current is opposite. That's why I have written here positive sign. So you see, in this case, what you are getting? In this case, what you are getting? That terminal EMF is greater than terminal PD. But when the charge is cell is recharged, then what is happening? Terminal PD is greater than the EMF of the cell. These 2 points are very important point wise. In most of the competitive exam, you will get question on this. So please remember and understand also these 2 points. Okay. When EMF is greater than terminal PD, when current is drawn from the cell, and when terminal PD is greater than EMF of the cell when the cell is recharged. Alright, means you are charging the cell. So here you have to write down the condition when the cell is recharged, or you can write during charging of the cell. Another point you must remember, that is under which condition EMF is equal to terminal PD, that is the cell is in open circuit. Cell is in open circuit means the cell is not at all operating, only the 2 electrodes are dipped within the electrolyte, but the current is not from the cell, not drawn from the cell, and not the cell is getting charged also. So these are the 3 points everyone should remember, especially for all the competitive type exam. Next is the expression for internal resistance. So we know voltage drop is given by current into internal resistance. So you see, internal resistance you can write it as small v by I. Again, the voltage drop you can write it as EMF minus terminal PD divided by I. Okay. Now you can write the this one current again, you know, according to this relation I am writing it here. Terminal PD is given by I into R. So one can write I as V by R. So you see, you can write it as V by R. So what is the relation we are getting? That R, it will become R, then it is E by V minus V by V. So what is the ultimate relation you are getting? That internal resistance is equal to, this is a very important relation, internal resistance is equal to external resistance multiplied by E by V minus 1. Okay. So these are all the relations you need to apply while solving the numericals. Now next topic is combination of resistances. Now you know that in electrical circuit we can combine then any devices by two ways. One is the series combination, another is the parallel combination. So what is series combination? When we connect any device, if you consider any device, then you will see all the devices are having two hands just like you. Okay, so if you keep all the devices side by side and left hand of one device connected but to the right hand, means all of you are sitting in a row side by side, okay, and you are just holding the right hand of your partner and then the left hand of your partner connected to the right hand of the next girl. So this is the way when you are making the connection, then that is known as the series connection. So if you consider here I said combination of resistances. So suppose we have taken the resistances of values R1, R2, R3 like that. And you see, look at it, how I have connected the left hand, right hand of R1 connected to left of R2, then right of R2 connected to left of R3, so on. And then the device, the combination is connected to a cell or a battery. Okay, so you see in a series combination, when you are connecting the device to a battery, then you see positive terminal of the battery current is coming out, and in front of the current only there is one path. Okay, so what will happen? The same current will pass through all the devices. So this is the most important point you have to remember, that for series connection, current is same for all the components connected in the circuit. But if you consider the different components, you see we are connecting the components across different points. Okay, and generally we find out the potential difference across 2 points. So here you see what is happening, as all of them, all the components, all the devices, all the resistances, as they are not connected across the same 2 points, so what will happen? Potential difference across them, it will be different. So what you can write, V is different. Here I have not written in means the full sentence I have not written. I same only written. What is the meaning? Current same through all the components, and like that V is different, V different across all the components, across the components. All right, but one thing here I would prefer to say, that is when I am correcting your work, then I am saying that whatever is written on the whiteboard, that is getting reflected in your work, but whatever I am saying verbally, some important point or anything, nowhere that you are writing. Okay, and that is not at all right for you, because sometimes I do not write everything on the board, but verbally I say. So when you are following the lecture, please note down the important points that I am saying verbally, just like here. I have written I same. I same means what? I same for all components. V different across the different components. Okay. So you see, according to this one, if I consider the potential difference across the point A and D, okay, I am writing it here. The potential difference across the two ends of the combination, let it be V. So you can write V is equal to V1 plus V2 plus V3, because potential difference is a scalar quantity and potential difference is the amount of work done to carry unit positive charge among the 2 points. Okay, so if V1 is the work done to carry unit charge from A to B, then from B to C, what is the work done? V2. Then from C to D, what is the work done? V3. So what is the total work done carrying the charge from A to D? It will be V1 plus V2 plus V3. Okay, so you can write that V is equal to V1 plus V2 plus V3. Now, V1 according to Ohm's law, you can write I into R1. Look at the diagram. What is the current passing through R1? I. So it is I into R1. Then for V2, it is I into R2. Then for V3, I into R3. So you can take I common. It is becoming I into R1 plus R2 plus R3. This is equation 1 we have got. Now coming the concept of equivalent resistance. Equivalent resistance is what? In place of the combination, we will use single resistance. Here you see I have used 3 resistances, but I will not use 3 resistance. Rather, in place of 3 resistances, I will use single resistance in such a way that the total current and total PD of the circuit remains the same. Okay, then the single resistance used is known as equivalent resistance. So, definition of equivalent resistance will never come in exam, but the concept is very important. So, what is the concept I said? First point, instead of a combination, you will use a single resistance. Okay. Then second point, you have to choose the single resistance in such a way that total current and total PD should remain the same. Not that in place of the combination as your choice you will choose the resistance. No. What is the condition for that? What is the restriction for that? That total current, total PD will remain the same. So I repeat, as it is the very important concept in physics for what is the equivalent resistance, that in place of the combination, a single resistance we have to use in such a manner that total current and total PD of the circuit remains the same. Okay. So, as that is the case, then you see you can redraw the diagram like this. That suppose R is the equivalent resistance. So, across AD in place of the combination, I have used the same means the single resistance R in such a way the total current is I. Neither the total current value will remain same as the previous one, and the total PD across the AD, it should also be V. So you can write V is equal to I into R for the second circuit. So if you compare equation 1 and 2, what are you getting? IR is equal to IR1 plus R2 plus R3. Right here, comparing equation 1 and 2, you are getting this. So you can write R is equal to R1 plus R2 plus R3. Alright. So what is the expression for equivalent resistance for series combination? That R is equal to sum of all the resistances. So from this one important conclusion one can draw, that for series combination, equivalent resistance is bigger than the individual resistances. Alright. So if you have, okay, there is no place here. Sorry. So suppose there are n number of resistance, equal resistance. Alright, equal resistance means, let us consider this way, R1, R2, R3. This is the way how many resistances are there? N number of resistance. Let the values be R dash. Then you see, you can write R will be R1 plus R2, then Rn. So, in place of R1 also R dash, in place of R2 also R dash, Rn also R dash. So, how many times R dash you have taken? N times, because there are n equal resistances. So, you can write it as n into R dash. So, this is another relation you must remember. So, how to find out the equivalent resistance for series combination? That you have to add all the resistances, okay? And if there are n number of resistances, equal resistances, then it becomes so simple. What will be the equivalent resistance? N times resistance, n times the value of one resistance, okay? N into R dash. And in case of series combination, another point you have to remember, that the current through all the resistances are same. So next one is parallel combination of resistances. So parallel means what? Suppose you are sitting with your partner face to face, okay, and then you are joining your left hands together, right hands together, then that is the parallel combination. So look at this diagram, R1, R2, R3 when we have taken, then all the left sides are connected to the point A and all the right sides, right hands are connected to the point B. Then that is known as the parallel connection. So if you consider this is the battery, then you see current is coming out from the positive terminal I. Then when it will come to the point A, in front of it there are three paths. So what will happen? Depending on the resistance present in the path, current will divide itself into three parts. So you see I1, I2, I3. Let us consider the currents passing through R1, R2, R3. Then all these three current after coming to B, what will happen? They will combine again and they will form again the total current and go back to the battery. So if you look at the diagram for parallel combination, which quantity is same for all? That is the potential difference. Just look at it. All of them connected across the same 2 points A, B. Okay. So for parallel combination, which quantity is same for all the devices, all the components connected in parallel? That is PD, potential difference. V is same. But look at the current. Current is different across the different components. Now in this case, you see one can write I is equal to I1 plus I2 plus I3. Alright, and I1, how you can write down? That V is equal to I1 R1, V is equal to I2 R2. So, what will be I1? It will be V by R1. What will be I2? V by R2. What will be I3? V by R3. So, you take V common. It is becoming 1 by R1, 1 by R2, 1 by R3. So I is equal to this. This is the first equation you have got. Okay. Now you just apply again the concept of equivalent resistance. So when you are applying the concept of equivalent resistance, what I said, in place of three resistances across the point A and B, you will connect a single resistance R in such a way that current in the circuit remains the same. So the current will become I only, and what will be the potential difference remains the same, that means V. So you see in this case you can write I is equal to V by R. So this is equation 2. So if you compare equation 1 and 2, comparing 1 and 2, what you can write? V by R is equal to V into 1 by R1, 1 by R2, 1 by R3. So 1 by R is equal to 1 by R1, 1 by R2, 1 by R3. Means for parallel combination, reciprocal of the equivalent resistance is equal to sum of the reciprocal of all individual resistances. So this is the point you are supposed to remember. Now if there are only two resistances, all these points are important. So you see you can write 1 by R1, 1 by R2. So if you simplify it, you are getting R1 into R2 and R1 plus R2. So you see what is R? R is equal to R1 into R2 by R1 plus R2. So this is the relation you must remember for two resistances connected in parallel. This will help you to solve the numericals in easier way, alright, in shortcuts, that R is equal to R1 into R2 by R1 plus R2. Then another point you must remember, R is less than R1 and R2, individual resistances. In case of series combination, what I said, R is greater than R1, R is greater than R2, R is greater than R3, isn't it? But in this case, you will see that R is less than individual. Just you consider one example. Suppose R1 you have taken 1 ohm and R2 you have taken 2 ohm. Then you see R will be how much? 1 into 2 by 1 plus 2 means it is 2 by 3 ohm. So 2 by 3 is less than 1 and 2 by 3 is less than 2 means R is less than R1 and R is less than R2 also. So this example you don't have to remember, just remember the result that for parallel combination always equivalent resistance is less than the individual resistances. Then another one is, suppose R1 and R2 you have connected in parallel and I current is passing through them, and we are considering I1 current is passing through R1 and I2 current passing through R2. Now in this case you see potential drop across AB, you can write it as this way, I1 R1, and you can write it as I2 R2 also. Potential difference across this one you can write it as I1 R1 or I2 R2. Is that clear? Now if you consider now this one, that I is equal to I1 plus I2. Alright, I is how much? I1 plus I2. Now I1 you can, this one I1 you can write it as V by R1 and I2 you can write it as V by R2. Alright. Now from this relation, from this another relation you can write that VAB is equal to I into the total resistance. What you can write? I into the total resistance. So you see from this relation one is getting I1 is equal to I into R by R1. But what is the expression for R? R is R1 R2 divided by R1 plus R2 into R1. So you see R1 cancel. You are getting I R2 by R1 plus R2. Similarly, I2 you can write it as from this relation. I2 is equal to I into R by R2. Now, what is the expression for R? R1 R2 divided by R1 plus R2. We are getting from here. And R2 is there. So, R2 cancel. What is the relation you are getting? I R1 plus R2. So, look at the two expression. How to get I1? I1 is total current into R2 divided by R1 plus R2. What is I1? Total current into R2. Now, not the resistance in that branch, resistance in the other branch, divided by R1 plus R2. Like that, what will be I2? I2 is equal to total current into R1. When it is 2, then it is 1. But the denominator is same. Denominator is R1 plus R2. Okay. So, these are the relations. If you want, you can remember. But while solving the numericals, if you can directly apply this one or by applying that first line I have written, VAB is equal to I1 R1 equal to I2 R2 equal to IR, you can solve it. Thank you, girls.